When developers attempt to scale monolithic agent frameworks, they invariably hit a structural wall. Hard-coded execution loops become incredibly brittle under production loads. Moving autonomous agents into reliable enterprise pipelines requires abandoning heavy, rigid class inheritance models entirely. DeepSeek AI engineered an alternative approach to this problem, DeepSeek Harness, an open-source, plug-in native execution runtime. This framework operates on a design philosophy called spatiotemporal composability. There is no central agent code. Every single capability is built as an isolated, modular plugin. To understand how this operates in practice, we are going to deconstruct three specific components: the Cordis microkernel, the event-sourced session log, and the programmatic code mode compiler. By eliminating a privileged core and treating the agent loop itself as a hot swappable service, developers can build fully customized workflows without inheriting upstream technical debt. The structural foundation of DeepSeek Harness is the Cordis microkernel. Unlike traditional frameworks, the Cordis context begins as an empty data bus. The agent driver, ReactLoopAgent, is a pluggable service that snaps directly into this bus. Other core systems, like Session Store and System Prompt, attach as equal peers alongside it on the exact same context tree. The complete plugin graph is constructed using declarative configuration layering rather than inheritance. Developers use a cordis.patch.yml file to dynamically hot-swap or override specific services at runtime, requiring zero modifications to the upstream codebase files. This architecture is governed by the lifecycle concept of reversible effects. If a plugin is unloaded, the microkernel automatically unwinds and destroys all of its associated typed events and listeners. This guarantees strict sandbox boundaries under ctx.scope, isolating execution environments so a sub-agent cannot leak its tool access to peer agents. A fully decoupled, reversible plugin architecture provides immediate teardown capabilities and clear separation of concerns, avoiding the entanglements of subclassing rigid base components. Most frameworks store prompt history as mutable strings or loose arrays, leading to unpredictable conversational drift. DeepSeek Harness rejects this approach entirely. Memory is handled by an event-sourced, append-only session store. Every interaction is logged as a strongly typed, immutable event record, such as turn start, assistant chunk, and tool call. This enforces a strict invariant. Model visible means logged. A pipeline called derive event message scans the log and synthesizes the exact prompt context. The language model is never fed raw arrays. Every piece of context is mathematically derived directly from immutable records in the session log. This strict event lineage protects long-running agents against process interruptions or unexpected network disconnections. When an agent wakes up after a crash, the runtime invokes a session repair mechanism called interrupted turn closers. It inspects the log for dangling tool calls and injects synthetic completion events, like tool outcome unknown, to securely close the gap before execution resumes. Because all state is derived directly from an immutable, self-repairing event log, the system guarantees 100% deterministic session replay and auditability. DeepSeek Harness separates execution into specific phases. A step represents one single request to the language model and the execution of any tools it decides to call. A turn is broader. It encompasses a sequence of 0 or more steps. It begins when the agent claims an input and closes when actions are fully settled. Transitions between phases are governed by a waterfall event middleware. At the agent/pre-step boundary, plugins can intercept, inspect, or entirely veto proposed input messages before the model is invoked. When a tool is called, it enters a 3-stage execution waterfall, beginning with the tools/pre-execute listener. This layer validates the proposed input arguments against strict JSON schema wireframes, halting the step if the types mismatch. This same boundary also evaluates the pluggable approval seam, accessed via ctx.get/approval, to handle human-in-the-loop requirements. Permission presets map actions to risk tiers. If an agent attempts a destructive shell command, the gate forces an ask state, pausing the timeline until human confirmation is received. Placing authorization and validation inside isolated middleware gates keeps the core React loop completely decoupled from security policies. The standard industry assumption is that AI agents must interact with external systems using individual native JSON schema function calls. This approach is computationally expensive. Sequential JSON toolchains force the model into constant ping-pong interactions, causing severe multi-round latency and rapidly exhausting token budgets. DeepSeek Harness bypasses this bottleneck through a mechanism called programmatic code mode. When enabled, the harness stops passing individual tool schemas to the model. Instead, it dynamically compiles the entire active tool registry into a single comprehensive software block. This compilation generates a strictly typed TypeScript or Python SDK definition encompassing all available commands. The prompt context collapses hundreds of potential tool options into one solitary primitive known as run code. The model's behavior shifts immediately. Rather than issuing single commands, it writes fully executable, multi-step programmatic scripts, utilizing standard loops and conditional logic. This script executes locally and synchronously against an internal code runtime sandbox. An agent can read 5 files, filter contents, and write updates to disk all in process, without requiring additional round trips to the language model. The final output buffer of that entire compiled sequence is then logged back into the session store as one single immutable event. Compiling an SDK for single-term programmatic execution eliminates the massive latency penalties inherent in conversational React loops. This is the unified DeepSeek Harness architecture: the empty Cordis bus at the base, the append-only session store projecting upward, the waterfall middleware gates, and the code mode sandbox. Data flows strictly from registered plugins through the log projector, past authorization gates, directly into the model. Achieving true spatio-temporal composability allows developers to build infinite workflow permutations, inserting custom plan modes or workflows without introducing technical brittleness at the core. By extracting orchestration logic out of the latency-heavy language model round trip and placing it into compiled, in-process scripts, the system operates at a significantly higher speed. The resulting execution environment is precise, highly concurrent, and deeply auditable. DeepSeek Harness establishes a new operational baseline for production agents, abandoning rigid conversational scripts to leverage microkernel modularity and programmatic determinism.